710 average daily flow, and we calculate pass-bys. If you're proposing to withdraw more than 10% of Q710 at the point of withdrawal, then you will trigger a pass-by. So just keep in mind that the Q710 is used for one purpose only. Are you going to be laden with a pass-by, or are you not? That's the Q710 function. Going to very briefly, kind of as a reminder, droughts occur naturally. SRBC can't control or prevent droughts. What we can do is minimize the impact of withdrawals when droughts occur. 10% of Q710, again, is that threshold. If you're proposing to withdraw more than 10% of Q710, you get a pass-by. What's average daily flow? All of these stream gauges that the USGS maintains throughout our basin collect data on a regular basis. We use the data from those USGS gauges to calculate these statistics for every point of withdrawal. So an average daily flow is the average of all individual daily flow rates for the entire period of record for any given stream flow gauge. So that's essentially Q710 and ADF, or average daily flow. What's a pass-by? When you think about pass-by, and I'll have a slide here in a moment, think interruptible flows. There are times when stream flows get low enough that we should cease all withdrawals, and that's where this pass-by comes in. And this is also where the cumulative impact analysis comes in. We look at the proposed withdrawal, and then we look at all existing upstream users. And we calculate what that cumulative impact is on the stream. And if it exceeds that 10% of Q710, even if this individual withdrawal we're looking at does not exceed that 10% of Q710, but cumulatively it does, then it gets a pass-by. So that's kind of how this whole pass-by process comes into being. And again, the bottom is just kind of a step-by-step process. If you're proposing less than 10% Q710, either individually or cumulatively, no pass-by. Greater than 10% Q710, individually, cumulatively, you get a pass-by. Again, with respect to pass-by, think interruptible withdrawals. When the flows get low, people have to stop withdrawing. They can't come back on the stream until it rains again, stream flows come back up past that trigger number, then they can resume withdrawing. They can never withdraw more than their docket allows. So even if there's a flood going on, if they're permitted for 500,000 gallons per day, they can only take 500,000 gallons per day. It's spelled out in the document. Very briefly, and I don't know how easily you can see this, but this kind of gives you the sense of flood events, individual monthly events, average daily flow, and the kind of the right hand of that bottom graph gives you some sense of what Q710 looks like, and 10% of Q710. The largest spike on the left is actually 100-year drought. The next one in is, I think that's April mean flow. The third one in from the left is December mean flow, then average daily flow, which is this number right here. And when we take this and blow it up, you can get to see it a little bit more clearly. Again, average daily flow, August mean flow, Q710, and 10% of Q710. Theoretically speaking, if this were a trout stream, it would be, the pass-by would be 25% of average daily flow, which means if the flows drop below 25% of average daily flow, they're off. They can't come back until flows get back up. So what does this look like? In this case, we're looking at 25% of ADF. That red dashed line is the trigger point at which they have to cease withdrawals. It's far above Q710, which we just discussed as a drought. It's far above 10% of Q710. So we do this to protect the stream so that when droughts occur, we've got adequate protection for the stream and the aquatic ecosystems that live therein. Summary of SRBC reviews. We try to be science-based in all of our decisions. We do cumulative impact analysis. We believe they are critically important. We do them on every project. Timing and location is important. It's not so much the amount of water that's being withdrawn, it's the location from which it's being drawn that we believe is just as important. Think interruptible sources, because we use those pass-bys to get industries, and this isn't just gas industry. These are all industries. We get them off the streams when the flows drop below these critical locations. Just as a reminder, we've got a website. It's www.srbc.net. You go on that site, there's a whole bunch of information on there. Just picking out a few of them, Water Resources Portal. I think we're one of the few agencies that is as transparent as we are. Here's the information you'll see on the Water Resources Portal. Not only will you see projects that have been approved over the years, you will see applications that are pending. These are applications that have not yet been completed, nor have the commissioners made a decision about approving or denying. They're in process. You can call those up. There are maps. You can find projects that are located close to where you live. You can open up that information. You can read application information on our website. You can again go back and look at projects that have already been approved by the commissioners. You can go to our Remote Water Quality Monitoring Network. We've got 50 sondes that are out in our basin, the upper portion of our basin right now, collecting data every 15 minutes. They collect six parameters automatically. They collect pH, temperature, specific conductance, dissolved oxygen, turbidity, and water depth. There are 6 parameters. You can see all of that data real time. Again, this data is collected every 15 minutes at these 50 locations. It gets uploaded through essentially a cell phone system, and you can monitor this afternoon at any one of these 50 locations that we're collecting data this morning. So we feel very strongly that trying to monitor things that are going on automatically in our basin is a very good thing. We also believe that sharing that information with you is a good thing. Another piece of information is the Marcellus shale or gas shale subpage on this website. You can go to that page, open it up, and learn a whole lot about what we've done, what we know about the industry. And if you go to that natural gas shale and natural gas well development page, the red dashed box is a copy of this PowerPoint. So if you've been confused, frustrated, or left in the dark about anything I've said, go to that website, go to that PDF, and you can call up these exact slides that I just shared with you. Thank you, Madam Chair.